In the last couple of math talks, we've looked at fractions, what they are, and how to add and subtract them. So now we're going to extend our operations to multiplication. And so I begin with the question, evaluate 2/3 times 4/5. Now, for many students, this isn't completely intuitive, and so I like to use a diagram to help you see what we're really trying to do here. So I'll begin with a square, and I'm going to make that square arbitrarily 1 unit by 1 unit. So in other words, each length is 1 unit, and the overall area is 1 square unit. And that's going to be really convenient for the calculations we're about to do. Next, I'll take the square and I'll divide it into 3 equal regions horizontally. And recognize that if I were to shade this section of that left side in red, that would have to be 2/3 of a unit in length if the overall length is 1 unit. And I've divided it into 3 parts. I think you follow me on this. And similarly, I'm going to divide it vertically into 5 equal rectangles, or 5 sections, of which I'll shade one edge that is 4/5 in length. And those 2 dimensions define a rectangle that is 2/3 of a unit by 4/5 of a unit. Now the area of that rectangle is length times width. Well, if we look at the shaded blue region of the overall square, there are 8 shaded little rectangles out of a total of 15 rectangles in that square. So the area, because the overall square is 1 unit, 1 square unit, the area of the blue rectangle must be 8/15. But then we also recognize that if you multiply length by width, that also gives you area. We can conclude that the 2/3 times the 4/5 must in fact equal 8/15. Now the question is there a more direct way to get this without a diagram? You might look at it and say 2 times 4 is in fact 8, and that would be correct, as well as 3 times 5 being 15. And that right there shows you how we multiply fractions. And it goes like this. For fraction multiplication, when we're multiplying a over b times c over d, we simply take a times c and write it over b times d. It's by far our easiest fraction operation that we have. Hardly any work at all. So consider 3 over 7 times 4 over 11. We multiply numerator with numerator, so 3 times 4 is going to be 12, and denominator with denominator. 7 times 11 is 77. The question's finished. Let's try a second one. 5 over 2 times 7 over 9. Once again, multiplying top with top, 35, bottom with bottom, it's 18. If your teacher wants you to give your answers as mixed numbers rather than improper fractions, you'd recognize that 18 fits into 35 once with 17 left over. So 1 17/18. Now I'm going to show you something that you really need to pay close attention to so it will cut down on the work that you have to do in these questions. Consider this question. 4 over 25 times 15 over 28. If we were to perform that straight up right now, we would get an answer of 60, the 4 times the 15 for 60, the 25 times the 28 is 700. And now we've got a big fraction that needs to be reduced. Rather than creating a fraction with large numbers and then trying to reduce it, we're going to reduce before we start. So let's get rid of what we just did there. And let's do it this way. We'll look at the 4, the 15, the 25, and the 28. And with fraction multiplication, you can reduce any numerator with any denominator. Watch what I mean by this. Something that jumps out at me is the 15 and the 25. They both end in 5, so I know that both those numbers are divisible by 5. So what I will do is take my 15 and reduce it by dividing it by 5, so it reduces to a 3, and do the same with the 25. So I divide 25 by 5, and it reduces to be a 5. Then I look and I say, well, wait a second, the 4 and the 28 are both divisible by 4. So reducing the 4 becomes a 1, and 28 divided by 4 becomes 7. Now I have new numerators and denominators and smaller numbers to work with. When I multiply the numerators, I get 1 times 3 for 3, and the denominators 5 times 7 for 35, and I get 3 over 35. Now, had we reduced the 60 over 700, we would have got down to 3 over 35, but that's a bit of a long path. Whereas this approach is much more efficient. You have to reduce your fraction anyway, why not reduce it up front? So let's try another. Looking at 8 over 9 times 12 over 15 times 5 over 24. Well, here we go. We're going to do all kinds of reducing here. Any numerator can be reduced with any denominator. So I might go directly to the 12 over 15 and say 12 is divisible by 3 to make it 4, and the 15 is divisible by 3 to make it a 5. Going further, I'd look at the 8 and say it's divisible by 8, as is the 24. So that produces a 1 and a 3. And then I would look at the 2 5s that still remain. So I would look at the 5 that was produced from the first reduction and say, well, that now can reduce with the 5 in the numerator that you see to the right. So they each divide by 5 to produce 1s. Now we're down to numbers with no common factors anymore, cannot be reduced anymore. If I multiply the numerators together, the 1 times the 4 times the 1, I will just get 4, and the denominators, 9 times 1 times 3 is 27. And I now have a fraction that is finished in lowest terms, and I have no more work to do on this question. So once again, I really encourage doing that fraction reduction before you actually perform the multiplication. Let's carry on. 3/4 times 14. Well, now we've got a fraction times a whole number. Well, that's really not a problem because we can always rewrite a whole number so that it is in fact a fraction. So we write it as 3 over 4 times 14 over 1. Once again, I look for any common factors, any reducing that can be done in the numerator and denominator. I recognize that 4 and 14 are each divisible by 2, so I go ahead and do that. The 14 becomes 7, the 4 becomes 2. That's all the reducing that can be done. So we get 3 times 7, which is 21, over 2 times 1, which is 2. And once again, if your teacher would prefer you to put that answer as a mixed number, you'd write it as 10 and 1/2. Just one more here. So we've got 4 2/3 times 3 3/4. The first thing I'm going to do in this is convert both fractions to improper fractions. So 4 2/3 is 14/3. 3 3/4 is 15/4. And now I look for any reducing that I might be able to do. Well, I can see that the 4 and 14 as before are both divisible by 2, so the 14 becomes 7, the 4 becomes 2. The 3 and the 15 are both divisible by 3, so the 3 becomes 1, the 15 becomes a 5, and so multiplying the numerators and multiplying the denominators, I finish with 35 over 2. And once again, if you want to go to a mixed number, it's just 17 and 1/2. Now, before signing off here, I just want to demonstrate for you why it is that when multiplying fractions, you can reduce the numerator of one fraction with the denominator of another. And I want to give you a little demonstration of why that really works. And let's begin with this. 6 over 35 times 7 over 12. Now, when we were doing this, we were reducing the 6 with the 12 and the 7 with the 35 to get an answer in this case of 1 over 10. Now you might say to yourself, why can you reach from the numerator of one fraction over to the denominator of another and reduce them? Well, this is the special thing about multiplication. Let me show you. If we re-examine this question and we say 6 over 35 times 7 over 12, well, we recognize this, that 6 times 7 and 7 times 6 are the same value. So we could just as easily say that we would get the same answer if we wrote our fractions this way. 7 over 35 times 6 over 12. That must give the same answer because it still involves multiplying a 6 and a 7, a 35 and a 12. Well, now we have two fractions that reduce in our more traditional way that we reduce fractions, which is the fact that the 7 and the 35 reduce to 1 and 5, the 6 and the 12 reduce to 1 and 2. And so we still get 1/10 as an answer. So when I'm working on two fractions or three fractions in multiplication, I really regard all the numerators as a single numerator. And so I can reduce any of that numerator with any of the denominator down below. And let me show you an extreme example of this. Consider this. 2 over 3 times 4 over 5 times 3 over 7 times 7 over 4 times 5 over 13. Now you could easily multiply this all out and then try and reduce. But watch what I'm going to do. I'm going to allow those numerators to move around to more convenient locations. And watch what I do here. I'm going to shift them around, and now I've got the numerator of 3 over top of the 3, the 5 over the 5, the 7 over the 7, the 4 over the 4, and just the 2 over the 13. Well, each of those first 4 fractions reduces to a 1. And so we have 1 times 1 times 1 times 1 times 2 over 13, and our answer is simply 2 over 13. Had you multiplied that all out and then started reducing, eventually you would get down to 2 over 13. But I think that's a cleaner, more effective, more efficient way to do mathematics. That's a lot of information. The next video will be on division of fractions. Thanks for watching.